In section 2.5, we're going to be focusing on different quadratic models, okay? There are endless real-world applications to quadratic functions, and one area that we often focus on is the area of optimization, which is the process of finding maximum or minimum values in a model involving quadratic functions. Okay, you're trying to optimize a situation by getting max or min values. All right, so here's one such situation. We have a ball being thrown upward from the top of a 40-foot building with an initial speed of 80 feet per second. And we have a function to represent the height of the ball above the ground over time. Okay, it's given as h of t equals negative 16t squared plus 80t plus 40. So h of t is the height of the ball at a given time. T is, of course, the time. Okay, so you can see we have a graph depicted here. You can visualize if I throw this ball up, gravity is eventually going to take over and it's going to push it back down. So there should be some sort of a parabolic motion to the path of the ball. All right, so I'd like to know when does the ball reach its maximum height? The maximum height, and then what is the maximum height of that ball? Okay, so basically we're trying to focus on the vertex of this particular parabola. Okay, we want that vertex right there. Um, Part A, they're saying when does the ball reach its max height? So they're asking for a time here. So they want it's like the instead of the x coordinate of the vertex here, we'll call it the t coordinate of the vertex. Okay, we can find that by simply using the formula t equals negative b over 2a, which would be negative 80 divided by 2 times negative 16. So that's negative 80 divided by negative 32, which is going to give me 2.5, and this represents a time in seconds. So it's going to take 2.5 seconds for this ball to reach its maximum height. Now, what is the maximum height? How do I find that? Well, I evaluate the function h with a t value of 2.5. Okay, and then I've already done that. I'll use my calculator. That results in 140 exactly, and that is feet in this case. Okay, all right, one more question to go along with this example. We also want to know, when does the ball hit the ground? Okay, now reason out, if your ball is hitting the ground, we're talking about this point right here. And that means we'd reason that the height of the ball is 0, okay? When it hits the ground, the height of the ball equals 0. So that means we need to take our function and set it equal to 0 and then solve for t. All right, now let's make this easy on ourselves. I'm noticing I can divide out a negative 8 from everything. That's going to just make my numbers a little bit smaller here. Take me to 0 is equal to 2t squared minus 10t minus 5. Once I get here, I would try to see if this is factorable, but it doesn't appear to be. So I'm going to solve for t with the quadratic formula. T is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Simplify that to 10 plus or minus the square root of 140 all over 4. And then I'm just going to approximate that. So if I did 10 plus the square root of 140, then divided by 4, I'm winding up with 5.46 approximately, and that's seconds. And if I did 10 minus the square root of 140 divided by 4, I'm winding up with negative 0.46. You can't have a negative time, right? So we can rule that value out, and we're going to keep the positive value of 5.46. That's how long it takes for this ball to come back down to the ground. Understand why you got a second value of negative 0.46. If you go back and you look at the graph, in a non-application scenario, this parabola would extend over into the second quadrant, right? And it would eventually hit the t-axis right there. Just doesn't apply to this particular situation. We're only in quadrant 1 if it's an application setting. Okay, moving forward, let me give you a specific scenario that often leads to a quadratic model. Okay, it's a scenario of revenue, and or it's a business situation. So revenue is the amount of money that you generate when you sell a product, right? It's not your profit, it's just how much money you're bringing in. And we have a very simple formula for revenue of R revenue equals X times P. So R is your revenue in dollars, X is the number of units you're selling, and P is the unit selling price, okay? So you take the number of units you've sold, you multiply it by the price that you're selling each unit at, that gives you how much money you bring in, right? Well, our number of units sold is often expressed to us in a demand equation. It's an equation that is often used to relate P and X together. If you think we talked about demand equations back when we were looking at linear models, right? Okay, so let me give you an example here. We have the marketing department at a cell phone accessories company. They found that the number X of iPhone 10R cases sold at price P is given by the demand equation. X equals 500 minus 20P. So right here, this is your demand equation relating X and P together. And notice they've put a little stipulation here that the price has to be between 0 and 25. Probably just want to make sure that the price of the case doesn't get out of control, doesn't get way too expensive, okay? So first thing we're going to do is express the revenue R as a function of X, okay? Express the revenue R as a function of X. Well, here's where this formula for revenue comes into play. R is equal to X times P, okay? And basically what I need to do here, if I want to express this as a function of X, that means I need to be able to write P in this formula in terms of X. So that's where the demand equation comes into play, okay? I'm going to take my demand equation and I'm going to solve it for P so that P is defined in terms of X, the number of units sold, okay? So to do that, I'm going to subtract 500 over to the left side. Then I'm going to divide both sides by negative 20. And I'll end up with P is equal to negative 1/20th X plus 25, okay? So now I've just manipulated the demand equation. It was given to me as X written in terms of P. I needed it the other way so that I can now take this expression right here, what P is equal to, and I can plug it into my formula. Once I do that, I can treat this revenue as a function of X. So instead of just R, I can now say R of X is equal to X times negative 1/20th X plus 25. And then I'll just distribute that X through. And notice what it gives me. It's giving me a quadratic function here, to represent my revenue. Now the revenue is expressed solely in terms of the number of items we're selling. Okay, so now we can do a few things with it. What quantity X maximizes the revenue, right? We want to optimize how much money we make here. So figuring out what quantity X maximizes the revenue means find the X coordinate of the vertex in that quadratic function we just built. So we're going to use X equals negative B over 2A. If you go back and look, your B value is 25, your A value is negative 1/20th. So that would be negative 25 over 2 times negative 1/20th. It's going to be negative 25 over negative 1/10th, which is equivalent to 250 phone cases. So to maximize our revenue based on the demand equation we were given that's relating how many units you're selling with your price, we want to sell 250 phone cases to maximize that revenue. Okay, well, what is the max revenue? All you need to do is take your function R and evaluate it with the X value you just came up with. Okay. And if I simplify that, that turns out to be 3,125, and this represents money. So this is dollars. So we're going to bring in a total of $3,125 when we sell 250 phone cases. All right. Now, part D, this is what, is really important for the company. What price should that company charge in order to maximize the revenue? Okay, based on that demand equation that is ultimately defining the revenue function, we want to know what price should we sell each one of these at so that we can bring in as much money possible. Keyword here to me is price. Our price was given with this equation. It's basically just the demand equation solved for P. And all I got to do is evaluate that with 250. Where the 250 come from? Well, that's the amount of items I'm selling. Turns out to be $12.50. Sell them for that much in order to bring in as much revenue as possible. Okay, that's it for this video.